Okay, so I just prepared brief introduction of IPv4, which we were discussing yesterday. So I was telling you about the IP addresses that it has 4 octets IPv4, and the first octet determines from which class it belongs. I told you the range is 0 to 255 for all the octets. If the IP address start from 0 to 127, it's class A, then it's class B 128 to 191. Class C is 192 to 223, class D, and class E. So it's all written here in the presentation. But nowadays, if you are talking about class A and the network start from 0000, the range is so huge that almost 17 million computers can be accommodated in this single network. And for each network in class A, you can represent 17 million computers, which is huge. So it's not distributed like that, someone give you class A address to use in a network. So we divide those networks into sub-small networks, because every IP you have to pay for it for the public IP. So same is the case with class B and C. Now the class D. The class D is specially designed for multicasting purposes, like someone is streaming their video. So you are not broadcasting to everyone, but you are specifically multicasting. Casting means television, it's broadcasting. Multicasting is you are watching Netflix. Some specific people are looking for specific content, maybe. So, and the class E is reserved for scientific purpose research and development, and we don't use it publicly. And among these addresses, I told you yesterday from class C 192.168 is a private IP address, and 172.16.x.x is a private IP address class, and then from class A 10.x.x.x is a private address, rest is all public. So the public IP addresses are those which travel over internet in a wide area network. What's a wide area network? I mean, it's the internet. All the web servers, public FTP servers, public DNS servers, public email servers, the cloud, all the services, they run on the public IP addresses. The private IP addresses, I told you yesterday, they are used in a local area network. What's a local area network? It's a network in your building, in your office, in your campus, school, university, college. And there we use the private IP addresses. Depending on the size of the network, you can choose whatever class you want to use. I was telling you class A is a very huge, very huge class. So we divide it into smaller chunks of networks, the subnetworks, and that is controlled through another field. I can show you. I can share another screen. Okay, someone is having problem joining the Zoom session. Let's see who's that. Okay, I was telling you, we have an IP address. I think I can show you the subnet mask here. No, I cannot. Let's see. Yes, from command line I can show you. Can you see the subnet mask? 255.255.255.0.
Yes.
Okay, we are not going into detailed subnetting, because if you want to know the range, you can nowadays go to Google, tell the subnet mask, tell the IP address, and it will tell you what's the broadcast ID, what is the network ID, and what is the usable range. So this subnet mask controls how many networks, subnetworks are available in the assigned subnet you have been given. Like if it is 255.255.255, the last octet is 0. You have complete /24 range. What is a /24 range? I can go to the board and tell you what subnet mask is. If I have an IP address 192 168.1.1/24. Mostly the network guys, they will tell you it's a /24, it's 25, 26, whatever. So the range, the DNS is 255.255.255.0. These are octets. These are also octets. 0 means 0. I mean, the range is, this is 8, this is 8, this is 8. 8 3s are 24. The subnet is 24. If it is /25, so you have logged this 1 bit of the octet. If you have logged 1 bit, this 1 bit, so this 1 bit is 2 power 8. I told you before, 2 power 0, 2 power 1, 2, 3, 4, 5, 6, 7, 8. What's 2 power 8? 2 times 8. I guess it's 192. Am I right? And this 0 to 255, can you unmute your mic so that I can interact with you guys? If there is no background noise.
Yes, we are here. Yeah, we are here.
So the range was from 0 to 255. If we are taking 1 bit out, this range is divided by 2. It will be 0 to 127, 1 range, and 128 to 255, the second network. If we take out 1 more bit to the subnet size, then we have 24, 25, 26. The subnet is 26, and you have further divided it. So that's how we do subnetting. And we divide the subnet by using this other field, the networking mask, net mask field. So it's just brief intro. If you don't want to absorb it, don't do it, just ignore it. So it was just how subnetting is done, but you should know what is 25, 26, 27, 28. If you don't want to know, leave it. And then this is called classless networking. If we take, okay, leave it. A classless addressing system or classless inter-domain routing is the way to combine 2 or more class C networks to create a /23. While we were taking 1 bit from the higher side network, from the last octet, if we start taking 1 bit as a network part from the previous octet, the network will grow. Like it was for /24, when it will become /23, the range increases. So that's how we can do the super netting. That's it. That's enough for I think this IP part. Let's see. I think I forgot to share the screen, right?
No, you were sharing.
I
Then
was
we
sharing.
switched to we switched to the board.
Switched to the board, and then the super netting. I didn't share anything, I guess. Anyways, subnetting, then super netting is what? From these octets, I will take 1, 2, 3, 4, 5, 6, 7, 8. So if I take 1 bit from this octet, so this octet will become what? 9 bits. So we will have a usable range in 9 bits, and we will have 23 bits remaining in our subnet part. So that's how we do the subnetting and supernetting and controlling everything. I think that is enough. You just should know the term. What's a subnet? What's a mask? And that's it. If somebody says you it's /24, you should know it's a /24 network, and my usable IP range is 0 to 255. The first, for every network, the first IP is not usable. It's called a network ID. And the last IP address is also not usable. It is called the broadcast IP. Anybody has any idea about MAC address? Okay. Every
MAC
computer.
address.
Yeah.
I think MAC address is a specific ID for each device?
For each device, and it is globally unique.
Right.
My cell phone has a MAC address. My laptop has multiple MAC addresses. Like I have a Wi-Fi card which is connected to the wireless Wi-Fi device. It has its own MAC address. And I have a LAN card in my PC. It has its own MAC address. So every device in a network has a unique MAC address, and we used to communicate through a MAC address. MAC address and IP, they both, why broadcast ID is using. Actually, this came into my mind why broadcast ID is used. One PC wants to talk to the other PC, but if the IP address is not known, how do you know where to go? Yeah. And if the MAC address is not known, how do you know I want to talk to the device through the MAC address? And in a local area network, the communication is not done through IP addresses. It is done through the MAC addresses.
Even with static IPs?
Even with static IPs. On a local area network, we communicate through the MAC addresses. Over the WAN, wide area network, MAC addresses are not allowed to travel there, only IPs travel. So how it is done? I have IP address, I have a MAC address. So this, I told you the last IP is the broadcast IP. My computer will send, it will be a bit complicated for those who have not studied AND operation. AND operation is what? If you do 1 and perform AND operation with 1, what's the result? 1. So if we perform AND operation with 0, the result is 0. If you have the idea of this concept, I can continue explaining this. Otherwise, I will skip. So anyone has any idea or no idea about the AND operation, OR operation, NOR operation? You have studied this thing in school or university anywhere?
I don't know.
Nobody?
I have little to no knowledge.
Huh?
We have learned this in the school days, but exactly not remember now.
Okay, so I have studied this concept in my older days a bit. I mean, in maybe 2004, 5, I guess, 20 years back. So
is it similar to the Python language?
No,
you have
no, it's just basic algebras and or if
Else are there?
Yeah, or if
yes.
functions.
Oh, there are programmers here. So if 1 and 1, 1, 1 or 0, 0, 0 or 1, 0. This is as simple as that. So let's explain it in a few minutes and then I will move ahead. So I say my IP address is, let's say, 192.168.1.1, and I want to talk to the IP address 192.168.1.2. I don't know the MAC address of 1.2. So I will broadcast in my complete network who has the MAC address.
अच्छा है समझ गए
11111111111. Who has got their MAC address 111?
नहीं जाके बोलना जाके बोलो बोल दो ठीक है बा नक्का जगह
somebody
I muted it.
somebody's mic.
Yes, I muted it. So I will send all the octets with 1. Everybody will receive this packet, and it will perform an AND operation. It will look at the IP address, and it will look at the MAC address. So everybody will perform AND operation. Let's say the MAC address may be 101.0.1.1.0.1, and so on. It will perform an AND operation. 1 is what? 1. 1 0 is 0. 1 is 1. 1 0 0 1 1 0 1. So actually, these both are the same. So if you're performing AND operation with all the ones, everybody will say, okay, this is my MAC address, I should respond. But when it will look in the other field, IP address, okay, no, the IP address is different, I should not respond. So whoever has this IP address will respond, okay, I am 192.168.1.2, this is my MAC address, and it will send its MAC address in the reply. So I am already sending my MAC address with a broadcast packet. So now both the parties have the MAC address of each other, and they will start communicating through that MAC address. Just take it as a concept that over the LAN, the communication is done through MAC address. This can be a tricky interview question, so you should know. I think we can go ahead. This is enough for the communication over LAN. You should remember it is done through the MAC addresses. The IP is there, but the MAC is needed. So now you have a web server. You want to go to internet. The traffic from the internet comes to you, to your web server. You're browsing your laptop. Anybody has a assigned static IP address? Most of you have done it. You have 3 fields, 4 fields, 5 fields available. If you want, I can show you. You tell the IP address. You tell the network mask. You specify the gateway and the 2 DNS servers. What's a gateway? Or should I show you? Anybody has ever assigned a static IP address?
Yes, I did.
So
Yes,
these
I
are
did.
all the fields. Let me show you.
Yes.
So you all know you have done it, and you have all assigned the gateway, right?
Yes.
So what's that gateway? Why it is used?
I think it's for accessing the network outside of your own network, could be internet or some other
Correct.
network.
In your own network, what you do? You have the MAC address. You know, I will broadcast the packet, and I can find the IP address and the MAC address and things I was telling you. But let's say we implement this scenario to the whole world, that one PC pops up, connects to the network, and it wants to go to Google. It broadcasts to the whole world that this is my MAC address, and I want to know the IP address of google.com, and I want to know the MAC address. So if I broadcast to the whole world, and there are almost 3 billion, more than 4.2 billion IP addresses in the world, and everybody starts broadcasting for the MAC addresses, for the IP addresses, the internet will go down, it will choke out. So the broadcasts don't go out of your local area network. It is controlled over your router in your offices, and this customer premises equipment, the small CP device, the wireless device in your premises, is also a mini router. So the broadcast will never leave your local area network, and then the gateway is used, and the communication outside your gateway is all done through IP addresses. So let's say the packet is very huge, but I will make a small packet. So I will take some fields. Source IP address is, let's say, 192.168.1.1. Source port. I told you before, every service runs through ports. Let's say my port is 717.000. My destination IP is Google. Google is maybe running on, let's assume, 43.20.10.1. And the destination port is 80 or 443, depending on HTTP or HTTPS. So this is the packet. I am assuming 192.168.1.1 is public IP. Right now I am assuming, otherwise I have to erase and write the public IP address. Because 192.168 is not allowed to go onto the internet. Let's assume it's a public IP address, because we are not involving netting here, which our device is doing. When this packet goes to google.com, of course, this IP address sees the IP address. This is not in my network, so it will send it to the gateway. Gateway will send it to the router. Then there is whole BGP, OSPF, and so many routing protocols running in the world, and reachability is, let's say, ensured. So when Google receives this packet, Google will reply back. Okay, Google has received the packet, and Google is replying you back with the content. We are not discussing the content here. We are just discussing how this communication is done over the network layer. So first, the source IP. I was the source IP. I was the source. Now, when Google is replying back, what will be the source? Can anybody tell me? Who is the source now?
Google.
Google is the source now. So what's the IP address of Google?
This 43.20.10.1.
10.1. Google received this request on port 80.
Yeah.
It will use this port in the source port.
Port 80.
Yes, port 80. The session was made on port 80. The session was made on port 80. All the traffic Google is listening. You cannot use while originating a packet. The source cannot use 1000 and below ports as a source port. It will be always be 35,000, 14,000, 50,000, 65,000.
No, I thought whatever it listens on 80 will read out to 443 because it's more secure.
Yeah. I am assuming the session is made on port 80. If it is established on port 443, it will use 443. Correct,
Okay.
you're right. So, but either you are making connection on port 80 or port 443. So I was taking one scenario. So it will
Okay.
use source port 80 or 443. The destination IP will be what?
192.168.
Yes. And the destination port will be this.
1700.
So this parameter, source port and destination port, this is also maintained by your CPE. And that's how it knows that this request was originated from this computer, because this is randomly assigned. And the one mechanism is that your device tracks what session is made from what computer to what website. And so I should send back this request to this PC at your home. So that's how important the ports, the IP addresses are important, and that's how they're used. Yesterday, someone asked that, will I continue with the SNAT and DNAT? I think I was pretty clear in SourceNAT. If anyone has any issue in SourceNAT, you can tell me. Many to one. I think it was.
I think
I don't
Karan was asking that question.
So Karan is
Yeah,
here
it
with
was
us?
me asking you. I was asking you if you were going to continue, but
So SNAT is any question with SNAT?
if you could just go over a little bit.
I mean, SNAT is like.
Jishan, if you don't mind, before we go ahead with SNAT and all, I just have a quick question on previous scenario.
Okay, so
yesterday-
I rubbed it.
No, it's okay. It's okay. Yesterday when we discussed between our home network or our home IPs will not be displayed over internet. So in the middle, CPE will convert that into a public IP. So how come
Yes.
in this scenario, is Google directly talking to CPE's public IP, or is that directly talking
CPE is public IP
Okay, and the public IP is again converting it back into
to the
our private
192.168. Yes.
192. Okay, all right. So there is a layer in the middle there.
Yes, that's why I said we are ignoring netting here, because then otherwise I have to rewrite it. Either
No
I
worries,
should
no
write a
worries.
public IP
I got
address.
it. Yeah.
Okay.
Yeah.
So
Just
Google
to-
is talking
just
to
to
my public
understand.
IP address. Yes, that's it. So
Okay.
I was telling you SNAT is, we all have our networks 192.168 dot, let's say 0.1, 2, 3, 4, 5 up to 254. Now I will not write 255. I told you it's a broadcast ID. So, and I will not write 0 here because it's a network ID. So 1 to 254. These all IP are assigned through a DHCP server to our client devices, our mobiles, laptop, tablets, and everything. They all want to go to internet, and you have one device, that's your CPE or your Wi-Fi device. That takes this IP address and do the SNAT, source NAT. It will replace your private IP with the public IP assigned to it by your service provider. So many IPs are coming, and they are going out with a single public IP address. So that's SNAT. Okay, Karan?
Yes.
Any confusion in this?
No.
No, fine. Now, I have a server, a web server, running on some network. Let's assume again 192.168.1.1. This is a private IP address. And my server is running on a private IP address. Because it's my company policy that all the servers will be assigned only private IP addresses and we have firewall placed in front of my server. So below my firewall, everything is private, and outside the firewall, it is internet cloud. It is the internet cloud. So if someone wants to access my website, which is running on 20.30.43.100, firewall will perform DNAT. I mean, firewall cannot do it automatically. We have to configure it. So whole of the world, many will come to this address. The firewall translates that, hold this, all the addresses below, and it will convert the destination NAT. And the benefit is that we can do multiple scenarios. If someone is coming on this IP address and this port, or this IP address and this port, on my server, these ports are listening on this IP address, the private IP address. So what firewall will do in a DNAT, it will take out this IP and send the traffic to this private IP port 80 and 443 to this 443. What's the advantage? The advantage is on our operating system, Windows, Linux, we have many other ports open. Many other ports open for your printer services or for your schooler services. For, I mean, in Microsoft, the ports are open and closed. I don't know for what. They are continuously, the ports are open and they're closing. So if you have vulnerability in your service and that service is listening on some port, if the translation is not done, someone is trying to connect to your port. Let's say there is port, some random port, maybe 143. Some service is running on 143. That service can be exploited. So if no NAT rule is applied, so when the traffic comes on firewall for port 143, the firewall will see, okay, there is no NAT rule available, so just drop it. There can be any number of scenarios. You have 192.168.1.1 and your application is running on port 80. So you want to tell that if someone comes on port 80, translate it to port 8080. Because somehow my web server is running, I have configured it to run on port 8080. But you cannot tell the whole world that please type http mywebsite.com port 8080 to everyone. You cannot tell it to everyone, but for some reason, you have to use this port. Because the browser, if you type http your website.com, it will always send request to port 80. There can be any other scenario. Your website is running on port 80, but you want the whole world that knows specifically, because you are not talking to the whole world. You want some employees to access some portal which is running on port 8080, and you specifically will tell that just whenever you type port 8080, you will be directed to some portal which should not be available to anyone. And if you will go with port 80, so general website will open, and if you will connect with port 8080, some specific website will open, or some specific URL will be available for you. So any mix and match scenarios can be implemented using DNAT. It gives you security. And the same concept after DNAT, you can further do the load balancing. We discussed load balancing yesterday. So the concept of DNAT is not for home users. The concept of DNAT is for the person who is running some service on some port and the world or many people wants to access it. Any confusion in this?
No.
Karan, you good?
Yes, I'm good.
Okay, so this is the scenario for the service providers. So what's the topic? What next topic for today? I think, yeah, for our firewall. In the old days, we had layer 3. I guess you have someone shared the OSI model. In that model, you can see that the IP addresses is on the layer 3 or level 3. So in old days, the firewalls used to work on the ports and IP addresses only. I mean, you can block an IP address, you can block a port, but you cannot block a URL. Somebody's typing google.com, the firewall, either you can deny port 80 or you can allow port 80. Either you can allow a specific IP or specific network, or you can deny. So these were the firewall policies in older days, but now the firewalls are very smart, and they can read the full layer 7. They can read the full layer 7 stack, and you can block any URL, you can block any application, you can block the torrents, and pretty much everything can be blocked through firewalls. So firewalls, we will discuss the basic firewall here. Today is the last day for networking. Tomorrow we will start doing the Linux stuff. A typical application is like we have a firewall. Firewall has some interfaces. What are interfaces? These are the, let's say, Ethernet ports with MAC addresses, with IP addresses. And okay. And in typical scenario, we have a switch available. I think should I explain what's a switch?
Yes, sir.
No, yes, but I have heard one yes. Okay. What's a switch? If you have 100 computers, either you can connect through wireless or you can connect through Ethernet or wired connection. So every PC will be connected through this one port. Okay. And I don't want to go ahead. I cannot go deep. They are is in the same local area network, in the same broadcast domain natively. If you have not configured it, the PCs attached to this switch, ideally they will be from the same network, and they will have the same IP range, and they will communicate to each other without going to the network, to the world. If they want to go outside, there should be some IP assigned. Like if this is network 192.168.1.0/24. So from this network, one IP 192.168.1.1 will be assigned here, and the firewall will take care of the routing. So traffic for the outside world traffic will go to this IP address, and it will take it to the outside world. So this is a switch. Let's say this is our web server. This is another switch. This is our DB server, database. We will discuss databases later. You have web server consists of mostly 2 items. I mean, you can use database if you have a very small website. I mean, you can avoid it, but if transactions are happening, data is you have user accounts, you have inventory system. So databases are used to store your personal information, user login account information. So they are stored in database. So database is very, very sensitive stuff. If we are talking about MySQL database, let's say it's running on port 3306. Here is our web server. It's running on port 80. Any user from the world, it comes to the firewall. It says I want to go on this IP address. The firewall will know on this IP address there is a web server running, and if the request is coming for the port 80 or 443, I should send the request to this PC. The page starts loading, and the page sees that, okay, I need to connect to database to get some credentials because the user is trying to log in, but the database is running on some another network 192.168.10.0/24. Let's assume. So the IP address can be from this subnet. I'm not writing it completely. The IP address is 100. So this machine will initiate a connection, and it will go to this data server on port 3306. This is called zoning. We divide the firewall into zones. There can be any number of zones depending on your firewall. So this zone, we can declare it anything, demilitarized zone. We can say it inside or DB zone or whatever you want to name it. So we tell the firewall the policy that if anyone from the world is coming, anyone, to the firewall, and the destination IP is this, and the port is source, source zone, source IP, source port we don't usually use, source zone, destination IP, destination zone, what actions you want to perform. Either you can permit or you can deny. Let's say our web service is running on port 80, so anyone from the world coming on port 80 is allowed to go there to the web server, but only if the source is 192.168.1. Let's say my web server is running on IP address 2, but if only the source is this, zone is DMZ, and if it wants to connect to the database server which is running on DB zone, and the destination IP address is 192.168.10.100, and the port is 3306. So only this PC is allowed to talk this database on port this, not any other port. So that is controlled through firewall and its policies. We define the zones, we lock everything. If this is the source IP address, if this is the specific zone, and if it is the specific destination IP address, destination zone, and destination ports, if these all criteria are met, only then the traffic can go to the database. Otherwise, anyone from the whole world is not allowed to talk to database directly. So databases are not exposed to the whole world. They are normally exposed to the application only and the administrator who is administrating it. So is this enough? We know about firewalls and IP addresses? Or there
Who's
is any
responsible to
confusion?
write the who's responsible for writing the policies on firewall or
Your
in the
network
firewall?
administrator, your senior network administrator, or your security administrator. I mean, it depends on the hierarchy of your organization. If you have a separate department of, I mean, security, and the firewall is handled by the most senior person, the change management is followed. Let's say it happens that someone opens a port, let's say by mistake, you're adding a rule, source any, destination any, destination port any, and you can connect. Fine. By mistake, you have used this rule. And mostly in all organizations, very few take care of it. The services are running on the default port. Like to access a Linux machine, we use port 22. It means you have opened the whole world to connect to any machine in your network on port 22, because port 22 is including in any. So everyone will start attacking your port number 22, and they will do the brute force attack. And if the password is cracked, and it can be cracked, it's no difficult task. It's very easy these days. So all your network will be compromised, and backdoor will be placed inside the machine, and you will not know. And when someone will realize it, it will revert the rule. But then the backdoor is there, and the backdoors can communicate through port 80 and port 43, which is already opened on the firewall. So
Okay.
this cannot be given to anyone who has no idea what he's doing.
Got it. One question in this scenario is,
Yes.
this source IP
Yes.
has to talk to database IP to get the username and password.
Which source IP, the web server or the client?
Client. Client will come to web. Yeah, client cannot talk to database directly, so web.
Yes.
But my question is, say suppose I didn't input any username and password in the source IP. So it will not even initiate a conversation with the database IP. Is that
It depends on the developer. What the developer can do it. If it's loading the page and the page required some information from the database, it will always go to the database.
Okay, so it all depends on
what
how
developers do. What developers do. The first thing they do is they connect to the database before loading the page, because it doesn't make sense that you are loading the complete page, and if someone is typing a credential, then you give him the error that my database is not working. So what they do is they pop up the message right away if the database connection is not available. So they've tested, they test it. This is the first thing they test. So if DB is there, every connection that is made, every time the page loads, it will test the database connection. If database is not available, it will not display the page at all. It will not display the website at all. And you will see the error connecting to database server. And
So
maybe
you mean to say as soon as the source IP start coming in to the firewall, it also initiates a conversation with the database IP?
yes, whenever the page starts loading. Yes.
Oh.
But the communication, like with the source IP coming into the firewall to initiate a web page, your web server is actually communicating with the database, right? So the web server.
Yes, the client has no idea what database,
Yeah.
what's the structure of the database. It will just get what the developers want him to show through his code.
Sure, through it. So the server and the firewall listening to a port, and as soon as there's traffic, so maybe like in the behind side, they initiate the database communication through the web server, right?
That's correct, and we will do it in our class. Don't worry.
Okay. Awesome.
I will host a sample. I'm not a developer, so what I can do is I can simply I can write a simple stuff that I'm connecting to database, and if the database is not there, the connection is not established, and we can pop out some error. So we will write a small code. We will install a database. We will give the database the permissions that only this IP with this username and this password is allowed to connect to me. I mean, you have told the firewall that this IP can talk to this IP over the network layer. But the application, the data itself, the database itself, you have to tell the database that that is my web server and only he is allowed to connect to me using these credentials. I mean, everywhere there is security implemented and still we got hacked. That's the irony. And this is the firewall. I mean, I don't want to go into detail. This is a very small firewall. Then we have next gen firewalls. They can detect the anomaly. We have IPS, we have IDS, intrusion detection system, intrusion prevention system.
Prevention system, yes.
Yes. Then we have these are worked on predefined signatures.
Okay, so what are the known threats are?
What are the known threats? Then we have sandboxes for unknown threats.
Okay.
What's a sandbox? You have a file coming in, it's clean, no signature matches. It will be sent to the sandbox. What sandbox does is it will open the file in maybe 100 VMs, all Microsoft versions, major Linux versions, and it will see if it is trying to access any part of this operating system which it should not be accessing to. So it's malicious.
Okay.
Block it, don't send it to users. Sandboxes. Then web applications, the web servers. For that we have specific type of firewalls which only works on layer 7. That are called web application firewalls.
Web application firewalls. Okay. And
specifically for web.
And these are also available as a service from different providers, right?
Yes, they are available and very expensive.
Okay.
And then we have for email, we have email gateways, email defenders, and still
People
we install the antiviruses on our web servers and database servers.
Okay.
With so many protection, still we the hackers they go through, so they always find some loop.
Yeah, obviously the rules are there to be broken, right? So
when DDoS happens, it happens in firewall. When DDoS attacks it. And I don't want to go deep into that, but let's
can I rub it?
Yeah, sure.
What's a DDoS?
DDoS is denial.
Is a nightmare to any service provider. It's the worst nightmare, let me tell you.
Yeah.
And I saw it happen.
Denial of service, right? Dynamic denial of service or something?
No, it's distributed denial of service attack.
Denial of service.
Distributed. D for distributed. Like you have 10 million computers, 10 million zombie computers. And there are, maybe
send their traffic to your web server or something. Yeah.
There are maybe over 1 billion computers. They're compromised, and you even don't know you are participating in an attack because there is some file, some service running on your Windows machine, on your home PC, and you don't know that this service is running. You never check that. Even I don't check what extra services are running, and there is a way to check it, but nobody cares. I mean, we log into our laptop and start, and the connection speeds are very high. But the problem is my web server. My web server is listening on port 80, which can handle 10,000 users simultaneously. The sessions are coming, dropping, connecting, the request is completed, and communication is done like that. There are so many types of DOS attacks, but let's assume only one scenario. I send a request to server. I want to make a connection. The server will acknowledge that. It will send an acknowledgement packet, okay, make a connection. And it will connect to the web server. This is the way the communication happens. You always connect to a port, the server give you acknowledgement, otherwise it will time out. If the acknowledgement is received, so that the client don't go into waiting for too long, as soon as it receives the acknowledgement, very small packet is sent for the connection and the acknowledgement, and then the server reserves the port for this communication to happen. Let's say 10 million people start sending the request, okay, I want to make a connection, and they are all different IPs. The web server say, I am reserving a session for you, and they never send back the connection. The connection is half open. It's not complete, but the server is waiting for the connection to happen, and it will exhaust all the ports on the server. And the legitimate traffic who is coming in, it will not be able to initiate a session. Either your memory will overflow, your network buffer will overflow, or your firewall session limit is, I mean, everything has a limit. So whenever any legitimate user will come in, it will not get served, and the distributed denial of attack is successful. So they come as legitimate user. So it is very, very difficult to identify which request is legit and which request is not legit. And it is one more scenario. Your pipe, your internet pipe in your data center is, let's assume we take it to the minimum 1 gigs. And 10 million users start sending traffic of 100 gigs. What will happen? This pipe is stopped. No extra request, which is a legitimate request, it cannot fit into this pipe because it is already flooded with the fake data. And it is a very expensive service. I mean, nowadays, maybe it is freely available with some packages in AWS, and still the Cloudflare, Akamai, they are very expensive and they are the best. So you cannot control it locally with your own devices. Like if I want to say it, okay, I don't want to spend so much money on the DDoS services, so I will install some device. No, you cannot do it. If the DOS comes to your firewall, trust me, how huge is the firewall, it doesn't matter. The CPU will be 100%. It will collapse. I have witnessed it many times.
Please mute the mic here.
Whose mic is this?
Yes, mute.
Okay, so this is distributed denial of service attack. Denial of service attack is easy to control. You can see this is one IP attacking. Okay, I can set the limit from one IP. You cannot make more than 100 sessions. If more than 100 sessions are coming, drop it. So denial of service attack is easy to use, block. But when it comes to distributed denial of service attack, it's nightmare. And you know, the attack can go up to 1 terabyte. I mean, Wall Street was hit with 1 TB per second, and they defended it. So that's when we say, wow, it's amazing. So 1 terabyte, more than 1 terabyte attack happens. So that's how huge it can go. So distributed, let me see what else we can cover. Let's, oh my God.
Thank you so much for explaining that.
Oh my God, I was not recording it.
Oh no.
Oh,
Recording.
Oh no, it is recording. It is recording.
Okay, it's recording, so fine. Are you sure? Yeah. Let's hope.
At least it's showing recording.
That's showing recording.
Okay, fine then. So this is how denial of service attack happen. And if you want to know any other topic, you can tell me right now.